Hey, everybody. Um, Thanks for joining in. I wanted to do a bit of a different stream today. I saw a lot of people were talking about that they might not, or they wanted to learn some animation implementation in Unreal. Or any engine. Unreal is just what I'm used to, so that's what this stream is going to be focused on. But yeah, this is meant for kind of if you're an animator and you don't really work much in engine. You haven't done a lot of implementing your animations. You just kind of are focused more on creating the animations, and you want to learn more about how to make them work in engine and how to blend between them and set up all of the everything that you want to set up in Unreal. So this is meant more kind of a beginner tutorial kind of thing. I have a demo project that I've made. I'll post the link for it there. This is the project that I'll be going through today. Kind of how to recreate it and reset it up from scratch. So if you haven't downloaded that, go ahead and grab it now if you want to follow through today with me. Or if you're watching this will be recorded, so if you missed it and you're watching it later, you can grab that and follow along with it later. So I see some more people are trickling in, so that's cool. Thanks for coming and hanging out. Hopefully we can get you learning some stuff today. So yeah, let me switch over. So yeah, this is a little project that I set up. I'll kind of just show you what we'll be going through today. So I have this little character, this simple character here. Hopefully everybody can hear me well, by the way. Hopefully my mic's working. Good. But yeah, so we have this simple character here, and I have some movement animations for him. He has a dynamically animating cape, so that it reacts to when you turn, kind of animates like that, and comes down when you stop. I also have some speed up animation, like some time scaling on the animation, so that when you move faster and you move slow, it slows down the animation like this. And then also I have some leans. We'll learn how to drive blend spaces and such like that. And then you can jump. And there's falling animations, different states with that. And then also I have these little orbs that are floating, and if you get close to them, he'll turn in his head and look at them procedurally. And then if it gets behind him, he'll stop looking at it. So there's like how to set up like a range, and kind of tweak these things as we get them into the animation blueprint, and to do fun things like that and implement that kind of stuff. So yeah, we'll just a quick, if you're in the chat, how many people have never opened like a blueprint before in Unreal? Just kind of get a feel for like, where people are at. So give me like a 0 in the chat if you've never really opened blueprints before, or give me like a 1 if you've worked with them a little bit, but Okay, 0. Got a 0 here, so that's cool. So I'll try to go, pretty beginner friendly. That's kind of what I want this to be. 1, just pretend 0. Cool, I gotcha. Yeah, so this what I'll be going over is particular to Unreal, but in terms of like how to actually do the things, but in terms of state machines and such like that we'll be making, like an animation graph kind of thing, like that should translate to other engines if you work like Unity or something. I've never used Unity, but I know that they have a similar thing, I think. But anyway, the terminology and stuff will be particular to Unreal. So, okay, so the first thing we'll do is we will, if you're following along, let me know if I'm going too fast. I want this to be, pretty casual. So please, I'm encouraging you guys to ask questions in the chat if you don't understand something, or if I gloss over it too fast, and let me know, and I'll try to explain it better. So we'll open up the content browser first. in this project. And it, with the download link that I already put in there. And so I have this test character here, and there's a animation blueprint, right? If you drill down into the characters folder, the test character folder, there's an animation blueprint here. So if we double click that, it'll open it up. And this is mostly what we'll be working with today. So this is, and when you open it up, it'll open it to the event graph. If you look right here on this tab. So I'll just kind of briefly explain some of the parts here. This is called an animation blueprint. This is what Unreal uses to tell what animation to play and how to do it, and all your code logic that you can do in here to like add stuff to it or whatever. So the event graph is events that happen and what you want to have happen when those events. So for instance here, I put these comments here to go over later, but essentially, like, there's the event blueprint initialize animation. That means when the game starts playing, initializes to start running animations, this bit of stuff will run. And the way that these work are, there's these little pins, these little white connector arrows, and it runs the direction that the arrow goes. So this will happen, then this node will happen. It's similar to like any other kind of node based software. If you use them like materials or there's a bunch of different that do that. And then down here is another event. This is update animation. So this runs every single frame of the game when the animation is playing. So all of this stuff, that's why you see these red lines are moving. It means like this stuff is being executed right now because we're running a preview right here in the corner. So this is your main viewport, and then there's some other tabs up here. So like you can click on this. This is the state machine, and then up here there's other things that you can click on. So this is the anim graph, which will contain all the information that we want into which pose should be showing for each frame. And then, there's these different tabs, so you can switch between the different graphs by clicking on these. Over here, we got our preview, so we can see what's happening. And then down here, we have variables and macros and functions and the different graphs. So you can also select our different graphs from here that way. And then the variables are what we'll be using to drive our state machines and our blend spaces and all that stuff. So I'll go over creating these later. I'm just kind of giving a brief overview of like, how does the blueprint look and stuff. And then over here in the details, there's nothing right now because I don't have anything selected, but if I was to select like one of these variables, you can see there's different stuff that happens over here in the details panel. And your layout might possibly be different than this, but the details panel should be somewhere. And this is where you can put in, an actual value if you want. You can set different properties and stuff in here in the details panel. And then there's also, preview scene settings and these, but we'll probably not be using these as much. And then down here, there's an asset browser, so you can see all the possible animations that are created for this character that you can use. Which is on this skeleton, because when you make an animation blueprint, you have to tell it which skeleton that you want to use, which we'll go over that when we make one. And then these are all the animations that are available for you to use for that one, which with the demo project, I've already imported them, so they should be there and good to go. And then these are just some preview settings that you can use for previewing your state machine when you make it and such like that. So this is an animation blueprint. There's the character blueprint, which is this one. We won't really be going over anything in here because this is more gameplay programming than necessarily animation programming, which is more animation implementation. But it works basically the same way. It's laid out the same. There's like these node graphs that you can use to look through. and the details panel, and then your variables over here. So it's set up kind of the same way. It's a unified paradigm kind of thing. Cool. So is everybody following along so far? Cool. So what I'll say is, if we're going to be running through this, basically recreating this animation blueprint from scratch is what I want to be doing. So the first thing we'll do is make a new animation blueprint. We'll still leave this old one, but we'll just make a brand new one. So all you need to do is right click inside of the content browser here. And if you don't have the content browser open, it's under Window, content browser right there. And then another way you can get it, there's a little thing called a content drawer down here, which is just a little docked version of it. You can also bring it up that way. I think there's a hotkey for it. Oh yeah, Control Spacebar, so you can bring it up that way too. But I kind of like to work with the floating window instead, usually on a second monitor or such. But anyway, you right click in here, and then there is if you bring up in here, there's animation, and then there's an animation blueprint. So if you click that, it'll bring up this little window, and then this has all the skeletons, the skeletal mesh. Do I use the latest version of Unreal? This one is 5.2, I believe. I think we're up to 5.4 now. So this one's a little bit older, but it's not that much older, I don't think. So all this stuff should be totally available in, I think, any of the versions of Unreal 5. I don't think we'll be doing anything that's in the cutting edge, like latest version today. But anyway, with the creating the animation blueprint here, this will have all the skeletons that are available to you to make an animation blueprint from. So this one will be doing the test character rig. So if you click that, I don't think we need to change any of these settings down here. This should all be fine. So we'll do create. And that'll make a new one here. We'll rename it. We'll just call this demo _ anim BP. And I like to put the anim BP in there, which stands for animation blueprint. I like to put them in there as a suffix. Some people like to do them as a prefix. This is just to help with like organization or whatever. So it really depends on, if you're working for a studio, like what is your naming conventions and such like that. Oh, hey Firestone, nice to see you. So we made this, and then we have one more thing that we need to do before we start working on this. We're going to open up the test character BP, not the animation blueprint, the actual regular blueprint for the character. And if you select the character here on the top, which is self, over here you'll see in the details panel it says animation, and then there's an animation mode, which is to use the blueprint, the animation blueprint. And then here we can select which blueprint we want to use. And since we're doing a demo here, we want to do the new one that we just created. So I think we called it what, demo? Yeah, so demo animation blueprint. So you want to do the drag down there and select that one to make sure that we're using that. And then once you do that, you want to hit the little compile button up here at the top. And that'll recompile the blueprint to make sure that it's, everything's working. So then if I take that and we hop into game, you can see that now there's no animation playing because we haven't done anything for our animation blueprint yet. So it's just a complete T-pose, whatever we imported the skeleton at right now. So that means that's good. That shows what we want to be doing. And then since we won't be working on the cape for a little while, we'll want to go into, this is just for the demo, but we'll go into this material instance here, the little blue one. And then under the opacity mask, which is right here, we'll check that and set it to 0, which will make it invisible. And we'll just save that. And then if we did that and look into game, now you can see the cape is gone. And I just wanted to do that to just so that we're not being distracted by the fact there's this long cape that's not animating as we're working on this blueprint here. So hopefully everybody's following along so far. Please, like I said, please let me know if I'm going too fast or you're not understanding something, because I want to help here. Cool. So if we open up the demo animation blueprint, now we can see that in our anim graph and our event graph, there's nothing here yet. So we'll start with the anim graph here, which is this one. And then you can see this note here, which says output pose. And what this is what the game engine is going to render at runtime. So this is the pose that it's going to be playing. And since we're not feeding anything into it right now, obviously it's not going to be playing anything. But if I was to take over here on the asset browser down here in the bottom where all these are the animations that are available to us. If I was to take say the idle, and I just click and drag it in here, it'll make a little player for the idle here. And if I take if I click on the little white mannequin symbol there, and I drag from it and then release over here onto result, and then I click compile right here, now you can see now it's playing that idle animation. But it only played it once, so it didn't keep looping it. And that's because you need to tell it that you want it to loop. So if you click on this right here, down, I think, let's see, where is it? Down here a little bit, there's a thing that says loop animation, and you'll just check that box. And if you hit compile again, it'll just keep looping the animation. So this is a way you can do, if you want to preview like specific animations, you can plug them in this way. This is not doing any kind of logic or anything, like, are you moving? Are you turning? Are you jumping or anything like that? But yeah, this is just a way to preview to see like, hey, how does it look in the preview there? And oh yeah, Ravenwolf says search is always a friend. Finding anything in the details. That is true. So up here at the top, there's the search. So if you can't think of anything, so like if I just wanted to say loop, I type in loop there, it'll filter out everything else except what says loop. So this is a great way if you're not sure where the setting is. This is a great way to find it that way too. That's a good point. Cool. So, hello, Draco Dragon 42. Welcome. So this is this is pretty simple. If I were to hop in game now, you can see he is playing the idle standing, which looks good. But as soon as we start moving, he's still playing the idle. If we jump, still doing that, because we haven't told it how to, how to switch animations to the ones we want it to switch to or anything like that yet. So how we do that, let's see. Hey, Tentacle Funk, welcome. So if we want to give it some logic on which animations to switch through, we'll use a thing called a state machine. So if we right click on here anywhere, just not, anywhere empty space on here. If we right click and we just start typing state machine, here at the top, there's a thing right here, state machine. So if we click that, it'll make this new node, new state machine. We'll rename it. Let's call it, sorry, the fire truck's going by right now. We'll call this animation state. We'll just call it that. You can call it whatever you want. You can be more descriptive, but, and you can have several state machines, but we'll just have one for this demo. Hey, HB Thingy, welcome. Ravenwolf says, can you go back and talk about setting up the inputs to even move the root of the character? I could. That would be that would be a bit more on like gameplay programming style of things. And I kind of wanted to keep this focused more on animation implementation. So assuming that you would already have a programmer to set up all your inputs and everything like that. I could maybe go over that later if people would be interested. But I did want to focus more on, working, say you're working with a programmer and, they're handling all the gameplay implementation, and you would be handling the animation implementation from there. But yeah, if I'm done and people want me to go over some of that, I can do that too. Cool. So with the state machine here, we'll just go ahead and hook that into our output pose here. So the same thing, you just drag off this and put it into there. And then we can get rid of this. So if you just select it and hit delete, it'll get rid of it. And then we'll recompile it. Every time you do anything, you'll have to, compile to see any changes. And it's also a good habit to get in the habit of saving before you compile. We're not doing anything particularly dangerous right now, but if you start getting more and more complex, you might accidentally make like a loop or something that happens. Maybe not as much in the animation blueprint, but you could get something that could potentially cause it to crash. So you always kind of want to make sure to save before you hit compile, just in case that it does crash, so you won't lose your work. So now we have a warning here on our animation state machine. This is orange right here. And down here, there's a compiler results. It'll show you all this. And it says, compile of demo MP, there was no entry state connection in animation state. So let's check out what that means. So if we double click on the animation state machine here, we'll go into it. And there's nothing here because, it's brand new. We haven't done anything yet. But there's this thing called the entry. And what the entry means is that whenever this state machine is called, whenever it starts working, it'll do whatever is connected to this entry pin. So all the warning was telling us was that, hey, you don't have anything connected to the entry pin, so it's not going to do anything. So what we'll do is we'll right click in here. And then there's a couple options here. There's comment, conduit, state alias. For this tutorial demo, we'll mostly just be focusing on states. So we'll just add a state here. And what this is a state that the character is in and the animation that you want to play in that state. So for this one, we'll call this idle. So we'll rename it to idle. And then if you click drag off of this, it'll start making this little arrow, and then we'll connect it to the idle right here. So now if we save and compile, what happens is it goes and you can see that it's saying, hey, the idle state is active right now. Now we're still not seeing any animation playing over here because we haven't told it what to do when it's in the idle state. So if you double click on the idle, on the state here, it'll go in even further. And then it'll say output animation pose, and we don't have anything hooked up to it. And this works just like if I was to go out, click out here to the anim graph again, this node works just like this node, except it's inside the state machine. So you can get back in there by double clicking to drill down. And then up here, you can see the different layers of how far down you're drilled into this right here. So since this is the idle state, we'll want to grab the idle animation from over here and have it as a sequence player, and then we'll just hook it in this way. And then we'll save and compile again. And now it's running, but we forgot to do our loop again. So if we search in the details loop and check it, save and compile again, now you can see he's looping. So if we go back out to the animation state machine, we have an idle state now. And so this is the concept that we'll be doing to make, all the different states that we'll be in. So we'll have, idle, moving, we'll be able to jump, and then the different things that come with jumping, which would be like falling, doing a landing animation, basically filling in all these animations that we have here. So we got the idle working, and let's just check it in game to make sure that it's doing what we expect. So if we hop back into the game to run it, you can see it's playing the idle just like we wanted him to. So that's great. And of course, we still haven't set up any of this stuff yet, which we'll be doing next. How's everybody following along so far? All good? Good. Perfect. Cool. So we'll make a second state now, and we'll call it. So if we right click, add state. We'll call this one. Let's call it run, because that's what we'll be doing. Hello, Michael. Welcome to the stream. Thanks for coming in. Can we watch the video recording afterwards? Yes, this will be recorded and it'll be on the VOD later. So absolutely, you can totally watch it again later. And I'll probably try to upload it somewhere else too, so that Twitch doesn't delete it in like 2 weeks. But yeah, no problem. This will definitely be recorded for later. So we made this run state, and if we drill down into there, and there we have a run animation right here, and we'll plug it in, and we also want to make sure that that one loops because it's a looping animation. So same steps that we just did, and then we need to tell it how we want to transition from idle to run. And this is where most of the work in the state machine comes from, is setting up the transition rules and how to blend between the two states and how to blend between the two animations. So in order to do that, we do the same thing where we drag off the entry to the idle. We'll do the same thing here. We'll drag off. Now there's two sections on each of these states. You can kind of see there's where it says idle here, and then there's this little like kind of donut square ring around it. And that's where you want to click to drag off of it inside of this little area right here, not on the actual idle itself, because then that's how you move the node around, but right here on the outside. And then you'll see this arrow, which will be pointing, and we want to point it to run like that. So when you do that, it makes this arrow, and it has this little icon here. And what this is your transition rule. So if we double click on that, we'll go in. And this says can enter transition, and it gives you a little Boolean pin here. And so what we need to do is we need to tell it, what do we want to have happen that makes this true? And when this is, because a Boolean is either true or false, right? So we need to tell it something. How can we make this true? And when it's true, we'll be allowed to go through this transition. So this is where you would get in contact with your gameplay programmer, or, we'll set it up ourselves here. But, this kind of stuff would probably be like, you would go to them and say, hey, I need this kind of data that I need, in order to be able to do the things that I want with implementing here. But in the case of here, what we need to do is we want to say, hey, if the character's moving, that's when we want to enter this transition. So what we need to do is we need to get movement information of like, hey, what's the speed of the character? Would be a good thing to use. Like, so if the character's at a 0 speed, they're obviously idle. And if they're moving more than 0 or a smaller threshold, then we'll say that this is true and we can start running. So how we're going to do that is in the event graph. So if we click up here on the event graph, we'll do stuff here in order to get what we need from that. So in here in the event graph, these are kind of grayed out, which means they're not being used right now, but we're going to start using them. So if we right click, and we'll want an event, which is event So we'll type in here event initialize, which will give us initialize animation, blueprint initialize animation. And so this runs when the blueprint first starts running in the game. And it only runs once. And this is what we need. So using this, which is right here, says get pawn owner. And some of this stuff is just kind of like, you know, there's a ton of nodes in Blueprint, a ton of stuff. There's no way I can possibly go over all of them, but I'll try to explain how these work, the ones that we will be using. So the first thing we'll want to do is we will want to drag off of this to the white, and that'll say, hey, what do you want to make here? And so we'll say what we need to do is called casting, and we will cast to our test character BP right here. And what casting does is it allows blueprints to talk to one another. So I can get information from a different blueprint. I can get, you know, like a variable or some other kind of like a Boolean or some other kind of number from a different blueprint that we can use here. So for the instance here, what we want to do is we want to get our movement code and we want to know, hey, how fast are you moving? So whenever you do a cast, you need to cast in a context, which is like, what's the context of the object? So in this case, that's what this pawn owner will do. This says, hey, what the player is controlling is what we want to know. So if you click on this little blue here and you drag it into the object, it'll connect it that way. And then that way we can say, hey, whatever the player is doing, that's what we want to cast to here. And then when the cast works, you can drag off the blue here. And so we'll look in here, and under our movement code, which is, we have base character movement right here. We have things like it's adding movement input and such like that. So we'll need to use that. So let me quickly refer to what I did in the demo one. I just want to make sure. Get velocity. Okay, cool. That's what I thought I would do. So since we'll be calling and trying to get information from the other blueprints a lot of times, several times, what we'll want to do is set a variable that is this test character, because we'll be calling it a lot, so we don't want to have to cast over and over and over again. So off of here, if you just drag off at the top, there's this thing called promote to variable. And it'll make this, it'll make a little variable down here as test character BP. We'll just rename it. So if you hit F2 down here, we'll just call this test character underscore BP. We'll just call it that. And so then if you click and drag this and drag it off, it'll give you like get or set. And so we'll use get. And then we can reuse this anywhere without having to call, you know, this function over and over and over again. Hopefully I'm explaining this decently. It's kind of a deeper subject in terms of like how blueprints work. But hopefully that kind of makes sense so far. Because we need to get our, you know, our forward movement speed. So the way we're going to do that is off of here, we can say, I believe it was get velocity. I believe it was. Yeah, so there's a thing called get velocity. So this will get, you know, whatever the character is moving, and it'll give us a vector which will tell us the direction they're moving. And if we also say get vector length, I think is the one. Is it vector length? Let me check. Yeah, it's just vector length. You don't need to do the get. So if you go off of here and you say vector length, what this does is it takes, you know, the magnitude of the vector and the direction and like gives us a speed. So and it gives us a speed in one value instead of 3, which a vector is 3 and a float is just one value. So this gives us a value that tells us what our character's speed is, and we can use this to tell what how to drive this animation. So please explain one more time, why is it important to know the speed of the character for the animation? Sure, we'll get into that. So the reason that we want to know is because we want to say, hey, when the character is still, we want to be playing the idle animation. And when the character is moving, which if the character's speed is greater than 0, they would be moving. If the character's moving, then we want to play the run animation so that they're actually like walking, right? And so having this speed variable will allow us to say, hey, we want to start walking and we want to start playing the animation for walking. And we can also do some other cool stuff, which I'll show after we get that working with the speed as well. Like we can slow the animation down so that when they're moving slower, the animation plays slower, or when they speed up, they can, we can speed the animation up too. And it'll be easier to see once we get that hooked up and working. So now that we have this, we need to convert this into a variable that we can use in the state machine. So to do that, it's pretty easy. All you got to do is click on this screen and drag it off a little bit. And there at the very top, there's a promote to variable. So if we click that, it'll make a set node. So anytime there's a set node, that means we're setting the variable, whatever we're feeding in, that's what we're setting this variable to be. So we'll rename this one. We'll call this move speed or something like that. So now that we have that, we need, anytime a node has this white arrow on it, that means it needs a execution pin, which means it needs to be told that it needs to be run. So in the case of this, we have blueprint update animation, which means it'll be called every frame, which we'll need to know the movement speed for every frame, because it'll constantly be changing every frame, right? So we'll connect this in here like this and save and compile. And so now we'll know what our movement speed is every frame. And if you want to make sure that you know what's happening here, there's a node in here called print. So if you type print, oops, sorry, let me do that again. If you type print down here, there's a thing called print string. And if you click that, it'll make a print node here. And what you can do is anytime you want to know, like, hey, what is this variable? I don't know what it is. You can connect this green into here and it'll print whatever this number is. So if you connect that into the print string like that and then compile it, you can see over here it starts printing on the left side of the screen 0 a bunch of times, and that's because the character's not moving. So obviously it's going to be 0. But the print will also work inside the game. So if we hop into the game now, it's printing a bunch of zeros, but if we start moving, see how now it's up to 600? And then it goes like this. And you can see that as we start moving, it'll start printing the numbers that we're moving, which is great. Because that's giving us a value for our movement speed, which is what we want. So that's a good way you can use to like debug stuff. If it's not behaving as you expect, you can use these print nodes. I like to use them a bunch for that kind of thing, but we don't need it. We don't need to actually be printing this at the moment, so we'll delete that. Now we are getting an error here, so let's see what the error is about. Idle to run will never be taken, which means we haven't set up our transition yet in our state machine because we were trying to get this. So let's go back and do that. So if we go back into our state machine up here, one of these tabs, we'll want to set our transition rule here, which is the going from idle to run. So if you double click on this to get back in here, we'll get back to our transition rule. So now we have movement speed. So we'll drag this off, put it in here, get move speed, and it'll make this node here so that we can use our movement speed to drive this. So what we want to do is convert this to something that can be true, right? So what we'll want to do is say, you drag off here, and then we'll say when movement speed is greater, so it'll bring up this operators list. There's greater, you can also do less than, you can also do equal, there's all these math equations. And what we want to do for here is greater. So we'll do greater. And we want it to be greater than 0. So when the movement is higher than 0, this will be working. And so then now we have a red Boolean, which can match into our red Boolean pin here. So just drag up, connect those. We'll do compile. And now we have a transition rule that says when you go from idle to run, you'll do that when the movement speed is greater than 0. So let's see let's see if it actually works in the game now. So if we come over here, we hop back in. Now he's running. But he's running even though our speed was 0. But the reason that happened is because if you notice, right when the game dropped in, he fell just a little bit, and since this value is set to be 0, just that little tiny bit of falling is what set him to start running. He's ready. Yeah, that's right. So what we'll also need is we need another transition, which is from run back to idle. So we'll do the same thing, the same way that we set this one up, except we'll drag from run back down to idle. So now we have, 2 arrows. We have one going this way and one going this way. And so we can define rules for each of these. So this one's the one we just did, from idle to run. So we'll want to do the same thing from run to idle. Except this time, what we want to do is that when move speed is less or equal to 0. Now, movement speed is probably never going to be negative, but this is just a little bit safer to do it this way. You could just say equal, but this one's a little bit easier to do. And this way you can actually have it be like, higher. You can actually have it set to like 5 or something instead of 0. But for now, we'll just leave it on 0. So if you hook it in that way, hook it in just like we did before. We'll save and compile. And now, if we hop into the game, it'll probably work properly. Yeah, so you can see he's standing here, he's idle, and then if I hit forward on the control stick, he'll start running. And then if I stop running, he'll go back to idle. So we got our first 2 states working here, which feels really cool to be able to stop like that, and he'll stop moving and playing the 2 different animations. How's everybody doing so far? Everybody following along pretty well? Yep. Cool. Excellent. So this is kind of what most of the work here in the state machine is doing, is setting these states, coming up with these rules to transition between the states, and then, implementing the rules, writing out your equations to make the things true to happen. Now there's another thing that I didn't quite cover already, which I'll do right now, which is in these transition rules. If you click on them, in the details, there's a lot of details here which you can change, but the one that is probably the one you'll be doing the most is these blend settings here. And these are very, very nice, and you can use these to control how the animation blends from one animation to the next, how long it takes, what type of blending to do here. This is where a lot of power comes in shaping how your animation looks when you get, they're coming for me. Yes, they are. I live on the same block as a fire station, so they go by a lot. So Sorry if they're in the background. I'm giving the secret forbidden knowledge. That's why they're coming after me. Um, but anyway, the duration and the different blend modes. So you can have all these different kinds of blend curves if you want. You can do linear, ease in, ease out of the different types. Exponential out and in, all these stuff. You can even make your own custom easing curve if you want. So this can get really powerful depending on how you're setting up your animation stuff here. But for now, we'll just leave this normal blend mode. But for the duration, we can change this and use it for a lot of different purposes. So for instance, let's say just for very ease of demonstration here, let's set the transition time to be 0, which means it'll snap right in to playing the animation. It won't have any blending at all. And then on the transition rule coming from run to idle, let's make it something like really crazy high so that we'll know for sure that it's blending longer. So let's set it to like 2. And this is in seconds, by the way, the duration time here. So if we compile that and then we hop in the game to check it out, you'll totally be able to see how the difference works. So if I start running, he instantly starts running, which feels good. But then if I stop, see how it slowly blends down? You can totally see when the blend goes down like that, because it takes 2 seconds to blend out of that. So this is a lot of the ways you can shape how your animation feels in terms of how it feels to play. You can play with these transition rules a lot and do it that way. But for now, we'll just set them both to be back 0.2, which is the default, because that feels pretty good for this instance. Now, there's one other thing that would be better with this run, which is it would be nice if when you turned, he kind of leaned as you started leaning to the left and the right. And also, it would be nice if when you move slow like this, he wasn't running full speed, because that looks pretty silly, right? It looks like he's running on ice or like a treadmill or something, right? So I think the easier one to set up first would be the slow the speed of the animation down. So if we go in here and we have our run animation, if we click on it, in the details, there's a bunch of stuff in here that we can use. There's this play rate, which means this is how fast it plays the animation. So this will be playing it at 1 time speed. If we set this to be, say, 0.2, and then we compile it again, and we hopped into game to take a look at it, and then we start moving, see how it's playing the animation slower? So if we could use our movement speed to drive the speed of the animation, that would be something cool, right? Because it would mean that when we're going slower, the animation plays slower, and when we move faster, the animation plays faster. So let's do that. So the way that you are able to control this is over here where it says bind on this little drop down here. If you bring that down, there's an exposes pin, which is at the very top. And if you click that, now there's a pin in here which we can use. Just like before, whenever we want to connect something in, we can use it that way. So if we grab our move speed, we could hook it in that way, but that's not going to give us exactly what we want, because our movement speed, I think, is 600 when we're running at full speed, and we don't want to play this at 600 times speed, right? That would be ridiculously fast. So what we'll probably want to do instead is remap that stuff into something that's usable. So if you drag off of here, there's a function called map range clamped, which is right here, this one. So if we bring that in, you get this node, which is very useful for kind of recontextualizing some float values that you might have, and to use them to drive other things. So in this case, we have an in range of what the in range will be is what value you're getting from this movement speed variable, and the out range will convert that into whatever comes from the output here. So since our movement speed at max is 600, we'll put that as the top end of our range. So we'll, from 0 to 600 will give us that. And since our play rate at 1 probably feels good at full speed, we'll just remap this to 0 to 1. So this says when we're moving at movement speed 600, we'll get a value of 1. And then anything in between will be mapped linearly. So for instance, if we were moving at movement speed 300, we'll get a value of 0.5. So that's how this map range clamped works. So we'll take this and we'll plug that into the play rate. Save, compile. Now if we hop in the game and take a look, this won't work on the keyboard if you're following along. You actually kind of need a controller to do this just because of the way I set up the inputs. But if you like half stick and start moving, see the animation's playing slower, and then as I speed up, now the animation plays full speed. And the nice side effect of this is that when you stop, you get a little bit of nice like ease in stop as he's stopping. So this is some really cool stuff that you can do, you know, to kind of tweak your animation a little bit further once you get it into the engine. So now that we have that, the e-stop is cool. Yeah, it is. And then you can totally control how you want it to feel by, you know, making different setups to feed into this play rate pin. And the play rate can actually go higher than 1. It doesn't have to, you know, stop at 1. Free transition, exactly. So there's a lot of cool tricks you can do in here of stuff like this that'll give you free animation basically, or tweak your animation and to be able to use it in a slightly different way. But now we want to get the left and right leans, right? So I've already made a thing called a blend space, and I'll go over that really quick. How many people have not really done importing animations into Unreal? Give me a 0 if you haven't really imported your animations into Unreal. You've mostly just worked in Maya or Blender or Max or whatever your 3D software package is. Zero. Okay, I can go over this really quick. I had all these set up in the demo project before, but in case you want to know how to actually import animations. So usually you'll want to use a format. I usually use FBX. Which you can, you know, export from Maya or whatever you use. I use Maya, so I'll just keep saying Maya, but it applies for any 3D software. You can do as FBX. So when in here, you'll just right-click in the content browser in whichever folder you want to put the animations in. So I have an animations folder, which is where I like to put them just for organizational purposes. If you right-click in here, or wait, is it right-click? No, sorry, my bad on that. Up here at the top, there's an import. So if you click that, it'll open up this, and then in the demo project, I provided these FBXs. I didn't provide the Maya files, so sorry about that. I think I forgot to put them in there. But you can practice with these if you want. It automatically went to the correct folder, I believe. Which is where these FBX files are. So all you do is click on there, click open, and it's giving me an error this time because it already exists. But just for purposes here, let's recreate really quick. So let me delete the jump. Actually, this might be a problem. Anyway, whenever you import, it'll bring up. Let me just import it into a different folder. That'll be easier to show you. I'll just put it in here. So if you bring in the falling animation, for instance, it'll bring up this window. There are FBX import options. And you'll need to pick a skeleton that you want to apply this, the big scary window. Yeah, that's why I was like, it's important that I kind of show this window because there's a lot of stuff in here. You want to be able to pick like which skeleton that you apply it to. So since we already have our rig, which is our test character rig skeleton, and that's what these animations are meant for, you can apply it that way. And we don't need to import a mesh because we're just doing, the bone rotation data. We don't need an extra, since we're just importing animations, we don't need the mesh information. We just want the bone information. And then depending on how your rig is set up, you might need to click this force front x-axis, or you might not. It just kind of depends on whatever you exported the rig as, was it Y up or Z up kind of situation? Because, Maya is Y up and Unreal is Z up. So you might need to click this, but if you forget to click it, it's not a problem because you can edit any of this stuff later. This is just kind of the initial import stuff. So that's really most of the only things you'll need to change in here, unless your project has needs for it. But for the most part, you should be pretty good to go with the default settings in here. As someone who does have to check that box at work, the horrors it creates. Yes, exactly. You will definitely know if you need to check this box or not based on how the animation looks. So we'll import there. And then you can click on it to get into it and look at it and see it playing. And if, for instance, here, I'll show you if I have that or not. So there is down here, there should be that checkbox. Yeah, force front x-axis. So if I check that and then I re-import, you can totally tell, like, well, it's a little bit harder with this guy because he's just spheres, but you can see his legs are all screwed up and don't look right. So this is one way you can totally tell if you need to check this or not. So I'll re-import that. Does not rigging Z up in Maya increase the calculations? Unreal need to do the correct for not being in Z up. I'm not really sure on all of the the rigging side of things. This is kind of what this checkbox is correcting for you. If you're asking if it's cheaper to like actually rig with Z up in Maya, I'm not sure, but that would make Maya very difficult to use because I don't think you can swap that in Maya itself. So I don't actually, the answer is I don't really know. So sorry about that one. Yeah, I don't think it costs anything during gameplay. I think this is just, converting it on import. And then it's not having to run it every time. I think you're right, Ravenwolf. So I don't think it's any cost to doing this or not, other than a little bit more time to import perhaps, but then it's done. So that's how you import animations, and then I'll get rid of this because we don't need it anymore. And we'll go back over here to our animations folder here. And then what we'll want to do is make a blend space. And a blend space, which I already have one here, but we'll just make another one. So if you right click in here, there's animation, and then there's blend space down here. Y up it is. Yeah, I prefer Y up myself. I'm very used to it from working in Maya. So if you right click in here and you do animation and then blend space, then you can pick which skeleton you want to use for your blend space, which in this one we'll do the test character rig, and we'll just call this demo blend. I always like to put blend on blend spaces just so I know what they are. It's a little bit easier. You can switch to Z up in Maya. Oh, I didn't realize you could do that in Maya. It makes sense that you'd be able to. But yeah, it could make it hard to like switch between different files depending on, since most people will probably leave it. So yeah, so we made this demo blend here. If we double click it to open it, this is a blend space. And so what blend spaces can do is you have these axes, you have your X and Y axis, and then you can use a float to drive the position of the blending on these axes. So for instance, if we wanted to have the character lean left and right as he's running, if we had 3 different animations, we had one where he's running forward, one where he's leaning to the left, animating, one where he's leaning to the right, animating. We could put all 3 of those animations on here and then drive the blend using those. So conveniently, we already have these animations here in our demo project. But we'll want to do a little bit of setup first. I like to click this use grid here at the top. And then that just uses a grid down here for ease of use. And then we'll want to set on our horizontal axis, there's this name field. And what this will be is the name of the parameter that we want to drive this. So this will be used in our animation blueprint. This will be the name of the thing that we want to label as what we're driving. So in this case, we'll call it lean. And then we'll want to set a minimum and a maximum value. In terms of leans, I like to do them, personally, I like to do them from -1 to 1, so that any number that's negative is like a left, and any number that's positive is a right. So we'll switch these to be -1 and 1. But this doesn't have to necessarily be this. You can set it up however you want. It's just a way to clamp the data to be within this. So if, for instance, somehow that whatever you're feeding in parameters to drive this got higher than 1, it would clamp it to 1 for you. So that's kind of what you can do with this. And then you can set your grid divisions. So you could make it like 6 or 4 or 2, you know, that kind of thing. Yes, programmers do like -1, 0, and 1 values. It's very good facts. That's the main reason why I learned to do it this way and keep doing it that way. So you make them mad and use 1. Yeah, it just makes them have to do a divide by 100 on all of their, or multiply by 100 on all of their values. So yeah, we can set our grid divisions there. We can do a snap to grid, which is what I like to use, so that I can be sure exactly what our values are going to be. So then we can plot our stuff on here. And in the case of our run leans, we're not going to really use our y-axis because we don't really have any slope animations right now. But a good use for the vertical axis is like a slope animation. So like if you're running and you start going uphill, you have an animation for that's a little bit, you know, more harder to climb uphill. And if you're going downhill, like you can lean back a little bit and kind of that kind of thing. So that's another use that you could use for the vertical axis. In the cases of that, usually we would call it like slope. And then you could actually feed in degrees here if you wanted to. So you could be like -45 to 45 so that, you know, that's the maximum slope pitch that they could go through. We're not going to set up this today, but you know, this is an example of something you could do with this. So in order to fill in these spots on the blend space, over here on our asset browser, we have the animations. And so we'll drag our run animation and we'll put it dead in the center like that. And since we turned on this snap to grid, that means when we drag it in, it's not going to allow us to put it on anywhere except these points on the grid. So we can know for certain that this is set exactly in the center. So you can see up here, you get a little preview value, which is lean value of 0, which is right here. And then so we'll want to put in our left and right animations the exact same way. So we'll grab run L and we'll put it over here all the way. And we'll grab run R and put it over here all the way. So now if you want to preview this, you can hold down Control and drag your mouse around in here. And so you can see the animation, how it's blending. let me change the camera a little bit from behind him so you can see it a little bit better. So you can see how he leans to the left and leans to the right, and when you're in between, you get a nice for free animation basically. Now, in terms of animation accuracy, whenever it's in between these points on a blend space, it's going to be the most inaccurate. So sometimes you will need to make extra animations because, you know, depending on what kind of blend space you're setting up, you might need to add extra points on here just to get more information so that it blends better. A good example is, say you had a bone like this, and or you had a leg, right? And it's and in Maya you animated an IK, right? So, and then you put the foot over here in IK and you slid it along the ground like this. You know, in Maya, since they're IK, it would keep the foot stuck on the ground, right, as it goes through here. But in Unreal, it doesn't have IK by default when you bring in these skeletons. Everything is FK, so all your animations have been baked into FK chains. And so in between, you'll get some error because the foot will just be, it'll just be taking every single rotation of every single bone and just putting it exactly halfway between those two animations. And so since there's no IK, the leg will probably be up in the air a little bit, as an example. So, you know, if you don't have an IK system built into Unreal in your game, because it's too expensive, or, you know, this is a background character, or, you know, something like that, you could possibly make another animation if you wanted to fill in this blend space and give it more information. That's another option that might be a little bit cheaper than trying to make, you know, a bunch of IK systems on all your characters. Yeah, so that's the rundown of blend spaces really quick. So we'll be using this in our state machine back in the animation blueprint. So instead of using this run animation directly, we can use our run blend animation, our blend space instead. So let's unhook that and feed that into the result here. And so now you can see we have a pin for lean and we have a pin for slope. And we're not going to use the slope because we didn't make slope animations, but we will be able to drive the lean with something, just the same way that we were driving our move speed to do the speed of the animation. And see, you can notice that we don't have that speed pin anymore, or we don't have that play rate pin anymore. And that's because by default it's hidden, but the same way we did it before, we just come down here in the details, and where there's play rate, just expose as pin, and then we can hook this right back into the play rate, and it'll behave the exact same way that we did before. And we can compile that, and we also want to make sure that this is looping, which is already checked, so that's great. So now we need to figure out, how do we drive our lean? And I think I'm going to take a quick break because I've been going for a little bit. I'm going to grab some water really quick and give you guys a little bit of a breather before we hook that up. So I'm going to take a quick break. I'll be back in about 2 or 3 minutes or so. And then we can get into that and keep going with setting up the rest of our state machine. So I'll see you in a couple of minutes. I'll be right back. All right, we're back. And if you're just joining, I'm going to link again the demo project in case you don't have it, if you want to grab it later or after the stream or whatever. This is the project that we're going through right now. And I have, I have comments over all this stuff in the demo project, so hopefully it's easier to follow. Cool, so we were gonna set up our lean here on our run blend space. And there's probably a few ways to do this, and I'll go a little bit into how I did this, but this would definitely be something that you would probably ask your programmer to give you a value for this, just to feed in here. But I'll show you how I set it up and how we're gonna get it in this case. So if I refer over here to our one that's already working, it would be this box right here. So in the character BP, I've set up in this function what I call a lean delta. And what this does is it's quite a little bit of math here, and I'll just kind of give you a quick overview of what it does so you can understand without getting too much into the math behind how it works. But basically what we take is we take an angle that our character is facing on one frame, or we take the angle that our character is facing on the current frame, and then we take the angle that the character was facing on the frame that just happened before, and we find out what the difference of that angle is, or the delta of that angle. And then using that, we can map that into a range that feels good of how much should the character lean. So we can say, hey, when that delta is pretty big, we can lean pretty hard. And if that delta is very small, then we can lean just a little bit. So that's basically what all this math here is doing. I'm just starting to get back into appreciating math as I've been working on this stuff. And I find it really interesting. It's kind of cool to get back into doing math like this. But yeah, I won't get in deep into all of this because we're more focusing on animation implementation. But basically you would be able to get a value this way. And so what I'm doing here is I'm setting our lean delta in this function on our character that we'll be able to grab in the animation blueprint now. So if I go back to our demo animation blueprint, we'll need to be able to get that value, and we'll do it the same way, in the event graph that we did to get our movement speed. And now, since we're having a couple of different things, it would be good to put comments in here so that we know we can easily organize our stuff here. So in Blueprints, there's an easy way to add a comment, which is you just drag select over all the stuff that you want to be inside the comment, and then you just push C on the keyboard, C for comment. So if you hit that, it brings up a little box. So here we can we can just say, sets our movement speed variable. And we can type that in there. And you can do stuff. You can change your font size. You can change your comment color and all of that stuff in here, how transparent it is and everything like that. Okay, fun comment boxes, colors. Give me a vote of somebody tell me what color should we make this box. We can do it that way. What should we go with? Green, pink, blue. All right, give me a vote. Give me a G for green, a P for pink, and a B for blue. And we'll see what gets the most votes. We'll make it that. We'll make all of our comment boxes these colors for the rest of the time. We got 2 Bs. I'm going to assume the people that voted or named the things they'll vote for their own color. Looks like blue's winning. All right, I think it's pretty safe to say that blue is the winning one here. So we'll make it blue. We'll do that, and then you can also drag this up here and drop it in there, and then you can use this as a palette kind of things to pick from here. So we'll just save that as our blue, and we'll use that for the rest of our comments. So we'll pull this over here. The cool thing about comments too is they kind of work as a container, so you can actually drag them around and it'll move everything inside the comment, which is very cool and an easy way to quickly reorganize your blueprints and keep them readable. And that's the other thing that I would like to kind of say as you start working with these blueprints and nodes and noodles and stuff. It's pretty important to try to keep them as readable as possible. So there's, as they call it, noodle etiquette, where you want to make sure that you don't have stuff like this happening, where like, or this, it's like, I can't read that. I don't know what's happening there. So it's really nice to be able to keep things in an easy to read flow state, like a nice flow chart kind of thing. And where it's easy to read all this stuff. And actually, there's another node that you can use, which is very useful. If you double click anywhere on an existing noodle, if you double click, it'll make this little dot, which is called a reroute node. And you can use this to shape the noodles to like go around things if you want. So in the case of this, I can put one at the very edge of the comment box like this as it comes in, and then that makes it really clean so that the comment box keeps the shape of that wherever I move it instead of coming down through the top. So that's a good way to do that stuff. And you can also create those just floating by typing in reroute, and it'll just say add reroute nodes, and then you can add one that's just floating there if you want. So now we'll be making another section of here. And what we can also do to make it even easier to read, we can make a thing called a sequence node. So if I drag off here from here like this, and I type in sequence, it makes this node here, which has do this and then do this. And you can add as many pins as you want here like this. And the way it works is it executes each of these in order. So the top thing will happen, then the first thing will happen, then index 2 will happen, and such and so forth down there. So this is a good way to keep things organized where you're like, I want to keep things easy to read, and instead of having this extremely long, in order, a collection of noodles that stretches really far, you can add the sequence node, so you can put them on top of each other and keep them really organized that way. So we'll do it this way. We'll do the second one coming off here. And what we'll need to do from here is we'll need to make a new variable. So I showed you how to make this one, dragging off like this and promoting to variable, but you can create variables from scratch too. So down here in the bottom left, under the variables section here, there's a little plus icon right here. And if you click that, it'll make a new variable. And so we'll call this one lean, because that's what we'll be using to feed into the thing. But you can see the variable type is Boolean, which is true or false. And that's not what we want, because it just makes that by default. So we'll do the pull down, the drop down, and this one will be a float. And a float is just, basically a decimal number. And it can be anything, like 1.2568 or whatever. So float is usually, and it's just a single number, so it's good. Float's usually what we'll be using a lot for that kind of thing. But there's also integers, and then other types in here, vectors and rotators and all of that stuff. But in this case, we'll be using a float. So we'll want to set this float. So we'll drag it out here and say set lean. So now what we need to do is we need to figure out what are we going to use to set this lean here. So if we grab our test character BP, so we'll get that. And then if you remember, I told you that in here, I was setting up a thing called lean delta. And so since we are, talking to our test character BP here, which is what we set up, in this, so that's what this variable is for. So if we go in here and then we just type in lean delta, you can see that we can grab this variable from our other blueprint to pull into here. So if we do that and we say get lean delta, so what this will do is it grabs, whatever this is figuring out for our lean delta, it grabs it so that we can use it in this blueprint. So if we just feed that into our lean here, and then we pull our connection, our execution pin, and we pull it over here like this, And just for now, let's go ahead and make a comment box around this stuff, you know, like this. And we'll say sets the lean parameter. And we'll make it blue, because we are making all of them blue now. I guess we could make them different colors, but we'll just make it blue for now. It won the vote. It at least deserves to. So there, we got that, and then we'll save and compile. Everything's good, and you can see that it's running, and it's running both of these, which is good. The reason that we see this running with the red flowing dots is because this blueprint is being run right now to show this preview right here. And that's why it doesn't really do that over here, like other normal blueprints that aren't animation blueprints, is because these are only executed at runtime when you're running the game. So they're not running all the time in editor. And that's obviously to save resources, because you know, it's kind of expensive to have, if you had all of these open and running all the time. It would just eat all your computer, you know, all your resources to do that. But it has to run these in order to update our preview here. So that's why they run all the time. And it's nice to kind of see these flowing to show the flow of the code as it's being, you know, executed. So give me a second. I'll take a sip of water there. And I made some tea, so I'm gonna pull the tea out of my infuser out of the cup real quick. There we go. Okay, so let's try this out. Let's see what we get. So if we go in here and we go back to our, what kind of tea do I have? I have oolong, actually. Some fresh oolong loose leaf that I just made. Which means I can sip on it all day, because oolong lasts. You can re-steep it several times, which is great. I love oolong tea. It's very good. Delish, yes, indeed. So let's go back to our state machine, and we'll go back to our run here. And if we take our lean variable, get, and we plug that into our lean pin here, and we compile and save. Now let's check it out in game and see what we get. If we go in here and we start leaning, you can see it's pretty jittery, right? Right now, it doesn't seem to be exactly behaving like we expect it or what we want it to. So if you see, if I start leaning a little bit, we get really jittery like this, and it's popping really fast. And the reason for that is because we're getting this information directly. We're not doing any kind of smoothing on it. So between one frame and the next frame, that delta can pop really fast. And you know, using a control stick, if you've ever looked at like debug information for like the position of a control stick, you know that those numbers change. They can have big deltas really quick in between each frame and be really jittery. So what we'll want to do is put some smoothing on this value so that, you know, if it changed it a lot over one frame, but then it popped back to what it was, having that smoothing would mean that it wouldn't have that jitter in it. It would just slowly, you know, try to slowly bring it to what the value that we want it to be is. And so this would be something that you would be doing probably, you know, as part of your animation implementation. If you got like a value like this, you would want to be able to set some smoothing on it and control like how much smoothing it is. Is it a slow smoothing? Is it a fast smoothing? And stuff like that. So let's take a quick look at what I did before. The other thing that we want, so this is the way I set it up in the demo, which we'll be doing right here. And the other thing I did was I did another one of these map range clamps before. because we want to, the other reason that it's popping is because we're getting raw angle data. So, you know, if the angle changed more than 1 degrees, we're going to be already at the edge of our blend space. So we'll want to remap this into something that's a little more usable for us. So let's go back to the event graph here, and we'll do a map range clamp off of this, which is the node that I showed you before. And I think based on the other one, I think what felt good was -5 to 5, but these values will be something that you would play with as part of your implementation, and, you know, find something that's suitable and feels good to you and for the game that you're making. So we'll change this to be -1 to 1 and -5 to 5. So this means that a angle change of 5 degrees will be, you know, our max lean. So we'll do that, and we'll feed that in directly to the lean. And let's see what that looks like with no smoothing. So it feels better, right? Like you can see it, but you can see how much he's still jittering a bunch. But it does feel a little bit more in line with what we're going for, you know? So we definitely need that smoothing. And this is something that maybe your gameplay programmer would do for you, but it's good to know how to do it yourself if you need to. So at work, I have a node that they made for me that I can do this, but I'll show you how to be able to do it with vanilla Unreal without any kind of extra nodes or you know, custom stuff. So we'll want to use this node called finterp2. And what this is it interpolates the numbers, the current that you feed in, and it tries to put it to the target. And it does that over a time that you feed it, and then a speed that you feed it. So hopefully this makes sense. So what it does, the current is, you know, whatever value you feed into it. So that's what it is at that moment in time. And then your target is what you're trying to change your number to. So say, for instance, our current number is 0, and we want to go to 1. So 1 would be our target, 0 would be our current, and then delta time would be, in the case of this, delta time will just be our game time. So it's just a constant, right? We want to constantly be updating this at a fixed rate. But you could feed into something else in the delta time. That's just like how much time is changing as it moves forward. And then our interp speed is how fast does it move between that. So if you set a higher number, it would blend to that target faster. And if you set a lower number, it would take longer time to blend to that. So if we want to use delta time and we just want to use our game time, you know, just a constant over seconds, over time, you know, time, it doesn't change, it constantly moves forward. So what you'll need to do, just make sure, let me grab, yeah, okay. So what you need to do is click here and say get world delta seconds. And this just gives you how much time has elapsed as the game keeps moving. So this will constantly be moving up at a rate of, you know, a second is a second. So this is what we'll feed into delta time. Don't want to get too much into that, I don't think, but hopefully that makes sense. You're just basically putting a clock in here and saying that's your delta time, and it'll constantly be moving up at a rate. Now interp speed, for now, we will, let me see what I put in here. I put 5. We'll put 5 too to start with. I think that's the one I felt good when I was doing that before. So if we think about this, our target is what this value is going to be, right? Because what we're feeding in is what we want our lean value to be. So that'll be our target. So everything that we just did, grabbing the lean delta from our other blueprint, That'll be what we want to feed into as our target. And then our current will be what it is on this frame. So since from here, we'll be setting this as our lean value. And since we'll be setting this, can you please explain one more time, why do we need the delta time? Yes. So the delta time, so in order for this node to work, it needs to know what is our unit of time to interpolate these values between each other. Like, you know, we need to know what is our unit of time to smooth this over time. So world delta seconds is basically just telling it, hey, in real time, you know, as a clock is ticking, that's what we want to be our time. You could feed in something else, but since we know the game will always be running, this will just give us a constant rate, a constant, you know, basically real world time, if that makes sense. Hopefully it does. Cool, gotcha, perfect. So yeah, so the current here, so since we're setting our lean every frame, right? This runs every frame. So we're setting our lean value every frame. So what we could use is, since our current will actually be what this lean is. So if we feed that into our current, and then our target is changing based on how we move. So that means this will constantly be smoothing the value to what we want it to be based on what it was previous frame. If that makes sense. This is getting a little bit more into programming, but you know, it's kind of important to understand that concept of changing something every frame and updating it every frame. Hopefully you follow along with that. Please let me know if I overcomplicated that explanation. We'll just fix that up a bit. Just make this a little bit cleaner, a little bit easier to read. There we go. Okay, so let's see what this looks like. So we'll save this and compile it. And we'll hop into game. And now as we run, now you can see it's nice and smooth. There's no more jittering. And you can see that he leans when we turn. It's a little bit easier to see if I kind of stick the camera behind him and keep it behind him like this. You can see how he leans as we turn. So that feels pretty great. And then what you could do in here, you know, if you were like, I want it to smooth faster instead, you could just increase this interp speed value to maybe be 10 instead. Compile, and then check it out in here. And now you can see he leans a lot faster now as you turn. So this would be another thing that you could tweak as part of your game feel pass for all your animations, is you could be tweaking this stuff. And a way to make it a little bit easier to tweak these without having to necessarily go in here and find this node and stuff, you could drag off here and make this promote to variable. So we could say this could be lean smooth time. We could call it that. And then you could, over here, if you ever wanted to tweak it, you could just tweak it right here instead. So you would have, you know, without having to find where this node is or anything like that, you could totally just tweak it right here. Let's put it back to 6. I think that would feel pretty good. Do we need to use a similar tweaks for all blending? Not necessarily. It really kind of just depends on, you know, what you're doing and how you would want to do it. In the case of this, since our value that we're getting, you know, the way that we're getting our value for how much we're turning over a frame, since that's so unpredictable and not a smooth and a very jittery value, running this smoothing on it will help us keep our animation from being really jittery. But you won't always have to necessarily do this. And you could just tell your programmer that you need a smoothed value, and they could make this for you. I just thought it might be nice to kind of show you a little bit of this, what you could do if in case that you needed to smooth a value yourself for some reason. But you wouldn't always necessarily have to do this. And honestly, some of this stuff that we're doing here in the update animation event, some of this honestly should be done in the character BP instead. But I thought it would be nice to show you a little bit of that world of stuff that you could do, so that you're not completely reliant on necessarily being like, hey programmer, I need this, I need this, I need this. You could be able to do a little bit yourself. Cool. So we got that, and we got our lean working, and it's feeling pretty good. And also you could change these map ranged values. If you changed these top values here, the degrees of 5, you could control how hard you have to turn in order to drive your lean. And the kind of the concept that you should learn from this, besides how to hook it up, the concept of that basically all of this stuff, as we're implementing the animation, all of it is just data, and learning different ways to take that data and convert it into something that you can use to drive your animation. So all of these things that I'm telling you, like how I set it up for this, isn't necessarily something that you would be using for everything. It's just a way that I figured out how to get this data to put it into the animation, to drive our states and stuff like that. So this isn't a like always do this solution. It's a kind of and that's part of what a lot of the fun of animation implementation is figuring out. It's kind of like a problem and solving it. Like how do I tell it to how to animate this way, or how do I tell it how to switch this state, or something like that. Being self-sufficient early on gameplay is a huge W. That is true. It is very nice, to not get bottlenecked so much by learning this stuff. You can be a huge asset to your team, being able to basically implement your work without having to rely on, and it gives you more control, right? It allows you to present the animation in the game the way that you want it to be, because a lot of times I feel like this is why I find it super important to get your animations into the game and watch them in context and see how they feel in context, because you can make an animation in your 3D software that feels really great, and then in the game it might not feel too great to play, even though it looks really good. In terms of playing it and pushing the buttons in order to make the character do these motions, might not feel too good. And learning all of this stuff is a great way to step towards learning how to make it feel good. Of course, part of that is the gameplay programmer's job. How does it feel to play? But it's good to work with them in tandem, to get the results that you want, right? Because our animation work makes their work look really good, and then their work makes our animation look good. So it's a really good partnership there, and it's good to learn this stuff so that you don't have to relay how you want your animation to look to somebody who's not necessarily an artist. Some programmers are, but some are way more not as into the art side. So being able to bridge that gap a bit is something very important, I feel like, and it makes you a huge asset to your team. Cool. So let's go back and look at here. I think we have all of this set up pretty well. Let's just clean up this a little bit, just make it a little bit easier to read. Something I like to do. That's another thing. If you make sure that your node graphs are clean and stuff, anybody else that has to look at your work, they'll know exactly what's happening, and it's a lot easier for them to come in and tweak your work. They should teach gameplay animation with implementing a bouncing ball. Start implementing early. That's true. A little bit of background with me, like I didn't learn any of this stuff until I was working in games. And honestly, a lot of this stuff I learned over the past few years because, or at least this particular stuff that I'm showing you right now, because at my job, we don't actually use these state machines. We have a lot of custom tools and custom nodes that we've made. And so the way I work might be slightly different than this, but this is based on Unreal. So this is vanilla. This will work. Basically, if you're working in Unreal, this stuff will work. But you might, depending on the studio that you're working at or whatever tools that you use, you might need to tweak a little bit of your workflows with these. So let's see. So we got our run state and we got our idle state. So what else do we need? We have a jump, right? And then from the jump, we have a falling and a landing animation. So I'll go through these a little bit quicker than I have been here because I know this took quite a bit to get going here. So let's just go through these a lot faster. Why don't we? So what you could do, we need to make new states, right? So if we click here and we say add state, we'll call this one jump. And then we need another one. We'll call this falling. And then we need one more, which we will call landing. Cool. So this, let me make sure that that's all the ones we need. I think that is. Yes. Okay, cool. So if we think about how do we want these to work, if we think about it, you can jump from idle, right? And you can also jump from run. So let's go ahead and make those. So you drag off of the outside and you drag it this direction into jump, and we'll do it from idle too. So now we have two new rules that we need for that. We'll set those up later, but let's just kind of work out our flow chart first of how stuff is working. Since we're kind of doing this jumping as a whole feature, and we need all three of these states. So when you're jumping, you will go into a falling state when the jump animation is finished. So we'll have like a falling animation when he's falling down. So that's something we'll need. We'll need to go that direction. But you can also, if you think about it, you can also be running and run off a cliff edge without jumping and go to the falling state, right? So we'll come from run to falling as well. We'll move this up a little bit so it's a little bit easier to see all three of the things. But we don't need to worry about falling from idle necessarily. Although I guess it could happen if the floor disappeared out from under you. But in the case of this, I don't think that's going to happen in our test case right here in our demo. So we don't need to worry about that. But this is kind of just charting out like what are all the possibilities that could happen. And that's a good way to think about making these anim graphs in the state machine is that way. So coming from falling, we'll do a landing animation like this. And then from the landing, we'll go back to idle. So hopefully all these arrows make sense. and they're pretty easy to read because they're pointing in the directions. So coming from falling, we'll always want to play a landing animation, which will go into idle. And then idle could potentially go back into our run, or it could go into our jump. And you don't necessarily have to go from landing straight to a run, although you could. And, this is kind of where the world is your oyster, right? Like, this is how you want to set up all your animations. Like, you could potentially make a landing animation that is running, and from there you would go falling to a running land into run. There's so many possibilities here that you could do, but this is the one that I set up for here, a bunch of states, and I think this is a pretty decent state graph for what we're going for here. So I'll do it like this, pull it down a little bit easier to read. So now we need to set up our animations that play in these. So we'll additive landing as you go to. That's another good way to do. I didn't, that's a good point. I didn't really, in the demo, I didn't really set up any additive animations, but maybe that's something I could talk about, another time. But additive animations are great, and I use them a lot at my work too. If you don't know what additive is, I'll tell you real quick. If you use Maya, they have animation layers. Additives are basically animation layers for Unreal. In the you can set a base pose for your additive, and then anything that changes from that base pose in the animation will add the rotation to whatever animation you're playing. So for instance, if you had an additive of a character that was like shaking because they're cold and they're shivering or something, and so your additive would just be, the character shaking like this, but then you could add that shake on top of like all your poses. So like they could shake as they're running, they could shake as they're standing there, and such like that. But that's another topic. Just wanted to quickly explain what those were. So we'll get into these. We'll go into and set up our animations that we have here. So we jump in here and we grab our jump animation. We'll plug that in. And our jump animation does not need to loop, but it's not looped by default, so that should all be good. We'll go back. We'll do our falling animation. We'll grab our falling animation from here and plug that in. Now our falling animation we do want to loop, so we'll want to make sure to check that box there. And then we'll do the landing animation, which should be here. We'll plug that in. And we don't want that one to loop, and it's not. By default, none of these loop, so pretty much you only need to check it if you do want your animation to loop. Okay, now we need to set up our transition rules for all of these. So from our character blueprint, we do have a thing down here that says when you jump, we're setting some Booleans here. It says, are you jumping? So we just need to grab this Boolean from here and bring it into our animation blueprint. And we'll do that the same way we've done the other ones, except this one will be super easy because we just want a Boolean. We don't need to do any of this fancy stuff to it. So all we need to do is grab that that Boolean directly. So we get test character, because anytime we want to grab something from our other blueprint, we'll use this. We'll pull off this and we'll say, I believe it was called is jumping. Yep, so we say get is jumping. And then we can use that to set a new variable. Oops, sorry, not set. We want to promote to variable. And this one is called is jumping. We can leave it that. I like to not include spaces in the variable names. That's just something I've learned from the way we do it at work. But it's totally up to you. And kind of anytime I have a Boolean, I kind of like to add like a is doing, is at the beginning, or can, or, you know, some kind of verb like that, so that you know, like, is this thing happening? Is it true? But that's just a naming convention. You can stick to whatever works for you. So let's put this in a comment box, and we'll say sets jumping state, and we'll change it to blue. Or, well, now I think we deserve the other colors. So I think one of the other one was green, I believe. So let's make this one green. Let's make it more of a forest green, darker green. There we go. Let's do that. So we'll grab our sequence and we'll hook that into here. And just for cleanliness sake, we'll make that reroute node, hook it into the beginning here so we can easily drag these around. We'll save and compile. So this one is setting our jumping, and we can use that in our transition rules in our state machine here. So this one we would use this one anytime we go to jump. So if we go in here and we say, hey, grab this one, is jumping, we'll get that. We'll set it to be, this one could just be plugged in directly. We don't have to do anything special to it, because when you're jumping, when that's true, we can do this transition. So that one's really easy to set up. And we can do the same thing here, coming from run, because it's the exact same rule that we want. So we'll hook it in that way, compile and save. And so now we know how to get to our jump, but we still don't have a way to get to falling or landing or back to idle yet. Let's figure out how to do the falling. And I believe, just because this is a default character blueprint from Unreal, I believe they have a just is falling state completely on there. So you can already grab that and use it. If I look in here just as a reference real quick to what I did, we'll do it like this. So this one will have one other step, and this is since the character is using a default Unreal one, like I said. So we'll grab our test character, and then from here, if we type is falling, it automatically finds it for us, because this is just built into the character. So this is a way to, for instance, like this is a good way to think of, like, hey, a programmer set this up for me. You know, they would make these booleans for you to grab from here. So we'll grab that, and since this one adds an extra node in between, because it has to grab the character movement component, which is part of this. It needs to grab that in order to get this boolean here. So we'll do that. We'll hook it in like that. And let me look again really quick. So I find that it's easier to think of the character being on the ground versus is the character in the air. But this is just me. You can set it up however you want. You might find it easier to do your state machine setting it up, saying, hey, this character's in the air, they're falling, so I want to use this just straight as it is. But for me, I think it's a little bit easier to set up our state machine saying, hey, are they on the ground? So what we'll do is we'll flip this Boolean to say, hey, they're not falling. So if you pull off here and you type in not, up here there's one called not Boolean. So if you click that one, it'll bring a node here that says big not. So basically now this will be true when the character is not falling. So they're on the ground, right? So off of here, we'll promote to variable. And instead of calling this one is falling, we'll call this one is grounded. Or sorry, not is ground, is grounded. And I just find that a little bit easier to think of it and set up our state machines that way. So we'll hook that in like that. We'll add our reroute node. Hook it in like that. set these up. We'll make our comment box around it by selecting and hitting C. Let's make this one pink. I think that was the I think that was another color that was called for. Make it real hot pink. Why not? Magenta almost. Do it like that. And so for this one, we'll call this tells if the character is on the ground. So we'll set it like that. And then we'll compile this, and now it's running. So now we can go back to our state machine. And then from jump, we can do a transition here, which is, we'll get is the character grounded, and we want to say, we'll flip this one again. We'll flip it back to not. So we'll do a not Boolean because this is the character is not on the ground. So if the character is not on the ground, we can go to the following transition. Then we'll go back, and the transition rule will be the same as up here. So we'll grab the run. We'll do the same thing. So we'll get is grounded. And we'll say not. We'll do it like that. Is everybody following along okay? Hopefully I'm not going too fast for you. I know I kind of picked up speed a bit, but I want to make sure that, check in and make sure everybody's still following along pretty well. Perfect, great. Glad to hear it. Cool, so we'll keep going. So now it makes sense, right? We say if you press the jump button, we go to our jump state. And then when the jump state finishes, actually we haven't set that up yet. So let's do that. Because what we want to say is that when the jump animation finishes, if you're not on the ground, go to the following state. So let's hop back into this transition rule, and we need to add another rule to here. But how do we do that? Because we only have one pin, right? Well, there's another cool thing you can do with Booleans, which is you can pull off of here. And if you type and, there's an and Boolean. And then if we hook that into the transition, so we can use this to say both of these things have to be true for this to happen. So what we want to do is we want to say when this animation finishes, if we're not on the ground, go to the following animation. So this is what a lot of setting up these state machines is thinking about this stuff. It's like, how could we see, how do we want to be able to tell when to swap animations? Can you show how to preview these transitions on the character, the asset editor? Yes, I can do that. I'll do that once we finish setting up these initial things. Actually, once I finish setting up this rule. No, you're right. Let's do it now. Let's show it now. So I will say it's pretty easy to show how to preview these things. If you click over here, down here at the bottom, there's this asset browser where we've been pulling these animations from. This is a good question, by the way. Thanks for asking. If we pull where these animations are from, there's also another tab here that says Animation Preview Editor. And if you look here, this will basically say, hey, any variable that we have over here, we can set directly right here. So if I click is jumping, you notice how it won't let me set it. Like I'm clicking it, but nothing's happening. The reason for that is because of the way that we're implementing this in the event graph. So we're running all this stuff and we're grabbing this information from the other blueprint. And since we're doing that, we can't do this. We can't set it because it's just being overwritten every single frame. So this is a little bit of a downside of, pulling the information this way, which is I want to grab the information from another blueprint instead of another blueprint sending me the information here, if that makes sense. So if I unhook this Oh, by the way, to unhook a noodle, to delete a noodle, all you have to do is hold down Alt and then left click it, and it'll get rid of the noodle for you. So that's a way you can delete that. So now if I unhook that, it won't be asking what this information is from the other blueprint. You know, it won't be doing that every frame. It'll just, I can set them directly now. So if I go back to the state machine and we go in here, we can actually set these ourselves now. So I can click is jumping, and you can see he played the jump animation, and now we're stuck in the jump. And see, is grounded is checked, but if I uncheck it, and then I uncheck is jumping, see, nothing still happens because we haven't finished setting up all of this stuff yet. So we're stuck in this jump state, and we can tell that, you know, our transition rule isn't working because we're stuck here, no matter like how we're setting these, right? So let's figure out why that's happening. Oh, and instead, let me see if I can get it back to, if I recompile. Yeah, and if you get stuck, if you just hit compile, it'll reset everything. It'll take it back to, you know, the entry point from here. So a little bit easier way to see is if I edit the movement speed to go up, we got to set it pretty high, but you can see that we can preview this way. So we can set our movement speed directly here. We'll set it back to 0. Now he's on idle. And then you can click in here and drag that way. And then lower it down. So this is a good way to check your previews too, without having to hop into game every time. But like I said, the downside of how we set this up, oh, and true, you can check your leans too. So if I go in here and do that, and then set our lean like this, you can see how he's leaning in space. But like I said, the downside to the way that we're getting this information is that we're asking for this stuff every frame instead of the other blueprints sending us the information when they run. So we're getting that information when this blueprint runs versus when the other one runs. Does that make sense? Hopefully I explained why we have to unhook this to use our previews here. If you implemented this a different way, where say you, instead of here saying, hey, let me get the movement speed from the other blueprint, if in the other blueprint you said, hey, every frame send this information to our animation blueprint, which you can do it that way too, which probably I would advise doing instead of the way that we're doing it here. But I did it this way so that we can mostly do all our work in the animation blueprint instead of worrying about this one. So hopefully that makes sense. So we'll hook up, we'll hook this back in like this and compile. So now that's a good way to preview, but now we can't edit these values anymore because they're constantly being reset every frame. And actually this is a good way to check your smoothing. If you look in here and I set it to 1, like that, you can see how it's smoothing over time back down to 1 or back down to 0, as you can see. So that's a good way to check your smoothing too, if it's working, by doing it that way. Cool. So where was I? Oh yeah, we were setting up our rules here. So we have from jump, we need to get to falling. And the reason it's not working is because we put this and in here, but we didn't hook anything into the and yet. So what we want to do is we want to say when this animation finishes playing and the character is not grounded, then you can go to the falling animation. So how do we do that? Well, if you look in here and you right click, and I believe it's called, if you just type time remaining, so you can say get relevant anim time remaining. So if you do that, what this does is it says what animation is currently playing, which is the jump animation, because we're in the jump here. What is the time remaining in that animation? So as the animation plays and gets closer to the end of the animation, this time will get 0 until it eventually gets down to 0, right? So we could just say, let's hook this in. When this is 0, then it's true. But there's a better way to do that, because what will happen there is you will never have any kind of animation blending, because it'll have to get to the very end of the animation and then it'll pop to the next one. But we want to be able to set our blending easily through these transition rules, right? So, but that time can be variable, because we could easily, you know, when we were setting up these blends here, where there's a blend time right here, this duration, we could set this, you know, we could change these later, and then we wouldn't have to remember to come in here and set this manually. So there's a way to do that. And that is, if you click here, and I believe if you type in blend, I believe there's a, if you type in blend duration, or maybe it's blend time. Can't remember the exact one. Let's take a look at our reference here and see what it was. If we look in here, crossfade duration, that's the word. So if we look in here and we change this and we right click and we say crossfade duration, so get transition crossfade duration. So what this does is it goes in here and it grabs whatever value you set here for duration. So what we can do is we can say that when this time remaining is less than or equal to the crossfade duration, so basically when there's 0.2 seconds left in the animation, then this will be true. And we can start blending, because you want to have that little bit of crossfade duration so that you don't get weird posing. And then this will basically make it so if you made the crossfade duration be longer, then this would start earlier. And if you made it shorter, it would start later, because the relevant time remaining would be, you know, moving in relationship to it. So this is an excellent way to set this stuff up, because then you can change your blend times and you don't have to worry about changing stuff in here to make sure that it matches, because it'll automatically just match for you. So if we set that, that should be good now. Cool. I'm going to take another quick break. I need to get some more water because I've been talking a lot, and I think you guys can use a little short break again. So we'll get going again in about 3 minutes or so. So hang tight, and I'll be back in a little bit. Okay, we're back. Cool. So I think we were finishing setting up these jump transition rules. I think I might have set this one up a little bit differently than I did in the example that's downloadable, but this is kind of a way to show that there's many different ways to set up these rules that could potentially work. It's kind of just figuring out which one is best for you. And I think this one will work pretty well. It's saying, is the character not grounded when the animation finishes playing? And if that's true, then, you know, go in to the next state. So let's also look at the run to falling. And we say, is grounded not true, enter the transition. And that makes sense. We don't need any extra rules on that, I don't think. So now we need to think, what happens when you land? Okay, so you're falling and then you land. The only thing we really need to look for is the character grounded, right? So once the character becomes grounded, we should play the landing animation. So that one's a pretty easy one to set up. We'll just check for, is the character grounded? If that's true, then we're good. And then finally, let's check that again. So if we go back and just unhook this again so we can preview in here, and we go back to our state graph here, we'll compile it real quick. So now if we go in here and we click is jumping, and then we unclick is grounded, and if we do that in succession really quick, so we'll click jumping, and then we unclicked is grounded, you can see it went to the falling state. So that's working. So let's recompile that to make sure, and we'll unclick that. So that's working. Let's say we start moving, so we do our move speed up. So you're running, and then let's say you jump. Then we go into the jump animation. But since grounded is checked, it didn't go to the falling. So if we uncheck grounded, then it goes to the falling state. So this seems to be working correctly. So let's set our move speed back down to 0. Let's reset all this stuff. By the way, if you click this little arrow, if you see this little arrow here and you click it, it resets your values to be whatever you have set as your default. So we actually want our grounded state to be our default. So if we go into our grounded Boolean and we check in here is grounded as our default value and then compile it, then in our preview settings here, if we uncheck grounded, now it has the little arrow. So this is a good way to quickly reset all your stuff if you want to, you're running through this preview here. So let's say we jump, and every time we jump, grounded becomes untrue. That's always handled for us. So if we just have to click both of these fast, like this, then we go to falling. At this point, jumping would not be true, but let's say grounded is true because you landed. So we click that, and you can see that it moved down into the landing state. So that's working great. That's working as intended. So it seems like we've got all this preview working pretty well. We just need to get from our landing state back to our idle state. So that's the only one we got left. So let's look in here. This one, we probably want to have 2 rules. We want to make sure that we remain grounded, right? And then we want to say when this animation is finished playing, go to the next one. So it's basically the same thing that we set up here, except it'll actually be almost exactly the same, except this not it won't exist. It won't be there. So let's do that. So we'll get is grounded. So if that's true, we'll feed that into an AND Boolean, like so. And then we also need to do that time remaining is greater or is less than, the crossfade duration. So let's go in here and say time remaining. So get relevant animation time remaining. So we got that. And we want to say is less or equal. We'll feed that into our AND Boolean and we'll hook that into there. And now we just need to get that crossfade duration. So crossfade, get transition crossfade duration. So we'll get that, feed that into there, compile it. And now let's go back and look at our state machine and try to see if we can get it to do that. So if we jump, then we don't become grounded. And now we're falling. We're playing our falling animation. We're no longer jumping now. And let's click is grounded. So it should go to the landing, and then it goes through the landing and goes back to idle. Cool. So that's all working and it feels good. So the next step would be to test it in game and see if we missed anything. So on the paper here, it seems like everything's working. We got all our transition rules, and we have our, we've been previewing it over here to see if it works, and everything seems to be good. So now the next test is to put it in game and give it a real test there. So in order to do that, we need to hook this back in because we do need to get those values from our character blueprint. We're going to save, compile, let's hop back in the game and see what we got. So we have our character here. We move, we've got our leans, which are working and feel good. We have our slow movement like this. If we push the jump button, he plays the jump animation, and we landed, but nothing's like he didn't play the landing animation. So something's funky there. We don't know what's up. So let's take a look. And actually, if you hit Shift F1, you can get your mouse back and the game will keep running. And we can look in here as it's running and maybe see what's happening. So if we go to our state machine, actually, sorry, this doesn't work. This works in other blueprints. So if we looked in our character blueprint here, we could see, you know, what it was doing on tick if we did it that way, but that doesn't work. So let's hop out of game. So we hit the stop there and we go out of game. So let's look back in our state machine in our demo blend. Or sorry, this one. So what happened was we jumped and we never went to our landing state. So let's think here. So what's wrong with this rule? Well, it is grounded. You know, did we ever set, you know, we need to think, did we ever set what our is grounded state is? And if you're not sure, there's another way to see where this variable is used. And if you right click it, and there's a find references. So if you click that, here will show you a list of everywhere this variable is being used. And then you can double click them and it'll focus the window on where they are. So you can see here it's being used in this transition rule. Here it's being used there. But let's look where we're setting it. So if we go here and we say, okay, so it's being set by the character movement. Are they falling? And if that's not true, then we're grounded. So that should be correct. So something else is probably the culprit here. So let's take a look at our example project, or our example version here, and see what if we did anything different on how that's set. And it looks the same, except if you notice here, I set this one after or before the is jumping. I don't think that'll matter, but sometimes you can be surprised by the order of things being different and how that can affect things. So let's try to change those and see if that fixes it. This is kind of part of the debugging process, right? So we're like, hey, the thing isn't working like I think it is. Let's see if I can figure out why. And there's just a bunch of things you can try, and you know that comes with the experience of what could possibly be wrong. And I don't know if this is the case. I'm kind of doing it on the fly here with you guys to see. So what we need to do is switch the order of these. So what you can do is turn, you know, if you alt click this, it'll unconnect it. And then what you want to do is you want to move this pin to 3 so that it happens later. And you can actually move connections without deleting them. If you hold down Control and then grab it, you can pull it out and then hook it in the new spot that you want it to. So that's a good way to like reorganize noodles if you want to without having to delete them and rehook them up in a different way. So then I'll grab from here and I'll hook it into this reroute node. We'll compile, save. So now we've changed the order. So now we check if the character's on the ground before we set the jumping state. I don't know if this will fix it, but sometimes, like I said, the order of things can matter, and let's see if this makes a difference. So we jump and we land and it's still not swapping out of it. So let's think again. What's going on here? Well, there's another debug thing you can do, which can help you figure out what's going on here, is I don't know which animation is playing right now. I have a hunch because he's not looping the animation. So I think he's stuck in the jump animation right now. And if you noticed on the graph, if I pull up the graph on our state machine, let me pull that up. We don't have a transition from jump to landing. So that means there's two bugs here. First bug is that we don't have a transition from jump to landing, so there's no way to possibly get to landing from jumping. But I think the bigger problem is that I don't think it's actually going to the falling animation. But there is a way we can check that. If you hit the tilde key, it'll bring up the console where you can type things at the bottom. Tilde key being the one right here, up here by escape. If you hit that, it'll bring up this, and you can type in, let me think what it is, because we have a custom one at work. So let me think what the actual one is. I think it's show debug space animation. Yeah. So if you type that, it'll show up, tooltip hints at the bottom as you're typing this. But if you type show debug animation and you hit enter, it gives you all this information here at the top of the screen. And if you look, let me get my mouse cursor. If you look right here, I wish I knew a way to kind of hide some of this other information, but I'm not sure how to do that because, like I said, we have a custom one at work that's a little more useful than this, to me anyway. But if you look right here, in this white here, it says jump. And then it has a W, 100%. That means it's weighted 100% to that animation. And then the P, 1.33 out of 1.33 means that's the current frame it's on. It's on, or the current time it's on. So it's 1 second, 1.33 seconds into the animation. And then this is the animation total length. So you can use this to help you debug what's wrong. So from this, I can tell that it's never actually, it never actually goes into the falling animation from here. What kind of information does our in-house? It pretty much does just this part right here. And it does it in a little bit different way of displaying it. But it's pretty much just this. So I don't have to worry about hunting down where it is from all of this. And it actually displays it underneath the character that's currently playing it, is the way it works for us with our custom one. So that one's good because then you can actually have multiple characters on screen and you can see underneath each character which, or thing that's animating, you can see what's happening and what's the animation's playing. Yeah, it's a bit more user friendly, and I find it way more helpful than this. But you can this also gives you a lot of information. It's telling you what's playing. It's telling you how many montages are playing, if you're using any curves or material curves, or it's just a lot of information. But I find for debugging animation, you're pretty much mostly going to be looking on this when you're looking at state machines and debugging this stuff. So this told me what my hunch was that we're not actually ever getting to the falling state. So our transition rule isn't right. So we need to think about what's happening there. And actually, I have another hunch, which is if I hop back in the game here, or I hop out and hop back in, and that gets rid of your debug. But also there's another way to get rid of it, which is if you type, let me bring it back. So if I type show debug animation, and here you can see when I start moving, you can see over there the white part. You can see how it's running through our blend space right now. It's a little bit hard because I can't pause it to show you. But you can see how it's running, and then it's doing our run right lean, then our run left lean, and then how much they're weighted in. So this can also be a lot of, and it gives us our blend space input right there, where you can see our X value is changing as we turn. So this is another good way to debug, your animation stuff and kind of see how it's working. But if you want to get rid of this without having to hop out of game and back in, you can just type show debug none, and then it'll get rid of it. So there we go. So my hunch is that because of the way we set up the transition rule, which was that the jump animation had to finish before it swapped to the next one, the jump animation isn't finishing before we become grounded, is my guess. So since we jump and the animation hasn't finished, it doesn't have a way to get out of this animation. So we set up a transition rule here that wasn't correct. So what I think we need to do instead is we need to get rid of all of this, because none of that's right. And if we just do the is jumping and we switch it to not Boolean, so now we say, hey, if we're not jumping, then we can go to the fall. And if you look over here, the way the jumping is implemented is that when you cancel the jump, we're setting it to not be true. This might be different depending on however your jump is implemented. This is the way this one is, so you can kind of help debug it that way. Because this does have jump canceling, where if you let go of the button as you're going up, you'll stop going up instead of a max jump height. Instead of going to the max jump height. So we have jump canceling. So that probably makes more sense. If we're not jumping, then we can go to the next thing. So let's go back and see if changing that rule fixed what we needed it to. Let's hit jump. We land, and we get a landing, and we can see that it's working. But the land, so that's great. We fixed that. We fixed that transition rule, and things are working better now. However, the landing feels a bit soft, doesn't it? It feels like it's just like easing into the landing, and it doesn't necessarily feel that good. This is where we'll want to change our blending times in our state machine. So if we go back to that, which is in here, when we go to our landing, we can see that it takes 0.2 seconds to blend completely into the landing. And the landing animation is pretty short. So that means that the landing animation is practically done before we start blending to the idle. So for landings, I usually like to have them snap directly to them because it gives that real like impact feel. So kind of any animation I have where there's like an impact happening, I like it. I don't like to have any blending on it at all. And if I do, it's a very, very tiny amount of blending. You know, like 0.05 or something, which is like 2 frames. Basically a frame at 60 FPS, a frame is about 0.03. So if you do it to 0.05, that's like a frame and a half, roughly, at 60 FPS. But in this case, I think we would just want to snap to it. So we'll set that to 0, and we'll compile that. Let's think on here, is grounded, not true. That's all good, I think. So now let's check our stuff again and see if that feels better. Yeah. See, now the landing has a little bit more oomph to it, right? And that feels a lot better to me. So this is a lot of stuff, you know, that's part of animation implementation, is checking these blend times and seeing that, like, you know, just changing that blend time made this feel a lot different, even though the animation is the exact same. So this is why it's kind of, you know, it's great to learn this stuff so that you can make the animation look like you intend it to. Because a lot of times if you just leave default blending on everything, you know, default blending times on everything, you'll get really mushy looking results sometimes, especially with shorter animations, because the blending will be covering up the entire animation just about. So you actually don't get to see any of the nice posing that you make that way. So let's see. So we get here, and if we run off the edge, then we're not jumping, and we'll just see if the falling state works, which it does. So cool, that animation transition seems to be working pretty well. And let's see if we can jump and go directly off of that, and that felt pretty good. You know, just jumping straight up there, playing the landing animation. That's cool. It even kind of looks a little bit like he's like, you know, mantling up these little steps, which, you know, hey, that looks pretty cool. It's a free animation, right? So yeah, so that all that's working pretty great. And I think based on that, I mean, we could do a little bit more testing, but I think pretty much our state machine seems to be working pretty well, and we got it all set up to cover all of this. How's everybody been following along so far? You know, this is a good check-in point, because we just made a pretty big milestone. We got our state machine working. We got all our animations implemented in the first place. You know, our basic stuff, our basic state machine going. There's other stuff we could do. Actually, I think I just saw something weird right there that just happened. It looked like he T-posed for a minute, but I don't know what caused that. So I'm thinking here, right there, I saw it. Let's see if I can get it to happen again. So I got to think about, you know, what caused that? Where did we miss something in our state machine that would cause that to happen? But I can't seem to get it to happen again. So I'm not sure. But at this point, if you were implementing the animations and such, I would just play around a lot with it and see, you know, there it is. I see what's happening. Okay, if we jump immediately after we land, we're T-posing, see? And I think I know why that is. But yeah, like I was saying, at this state, I would be playing the game a bunch, you know, checking out my animations, seeing if they look great, seeing if there's anything I could improve with blend times, see if there's any kind of transition rules that might be weird, like I just found with this. Does anybody have any guesses as to why this might be happening? If you jump as soon as you land, why he's T-posing? Just curious if anybody has any guesses as to why that might happen. Let me pull up the state machine so you can take a look. If you jump as soon as you land, why do you think you'd be T-posing? No transition from landing back to jump. Doesn't know if it's on the ground or if it's in the air. Both of those are good guesses, and I think Bats is right in that we don't have a rule that says from landing to jump. So what's happening is we're actually going to idle. We're not T-posing, but the idle very much looks close to a T-pose. So we can't really tell. So what's happening is we land, and if we press jump before we get to idle, we are in the idle state, and then we are stuck in the idle state until we start falling, because we go through the run because we're moving, and then we fall and we land, and then it finally loops back around. So what we need is a transition from landing to jump, and we probably might need a transition from landing to run, but it seems to be working pretty well, just flowing through this really fast like that. So we might not need that, but we might. So it's good to, like I said, it's great to play around with this stuff just to see like what might be missing, or what kind of weird states can you get where you're missing a transition. So that's a good one. Let's see if that fixes it. If we go from landing to jump. So all we need is probably the same here, which is just is jumping. So that should be a really easy one to set up. So let's just grab that, is jumping. Put that in there. And let's give it a shot. Let's see if that fixed it. And actually, I left the game running, and we compiled save. Let's see if we can just see if the without closing the game, if that fixed it. And it did. So you can actually edit the blueprint, or at least you can edit the state machines while the game's running if you need to. So you don't actually have to hop out and do it every time. Wild server hosting, new to Unreal. Well, this is hopefully here to help you to learn about that. This is meant to be helpful for very beginners to animation implementation. So thanks for coming in, hanging out. Just went over a lot of stuff. I've been going for a couple of hours here, so there will be a VOD of this, so you can check it out later for anything you might have missed at the beginning. But please ask questions if I go over something too fast. And I'll let you know if I've covered it already, and you can rewatch maybe to get back to it. Cool. So we got that where we get the landings and we can jump immediately. That feels pretty good. Let's see if there's any other kind of weird states we can maybe think about. Let's see if let's make sure that we actually get to the falling animation, which means we have to jump for a long time. So let's bring up that animation debug again. So if you type in the console, oh, you're asking if I was new to Unreal. No, I've been using Unreal for probably 7 years now. But I'm a little bit newer to doing blueprints and stuff like that, maybe for the past couple of years. So this stuff that I'm going over here is I've been doing this stuff for about 2 or 3 years now. So yeah. If you type in here, show debug animation, and then we'll just make sure that it's going to our falling state, which I did see it. It's a little hard to see because it's popping around so fast, but I did see falling animation sequence pop up there. So we are transitioning to that, so that's great to see. So we can get rid of that. Show debug none. Cool, so I think we've got all of our states now that we wanted to get based on these animations. It's all feeling pretty cool. How's everybody feeling? Do we want to do the last two things, which are to show you the scarf animating really quick and then a head look? Or is this feeling like an overwhelming amount of information and we should maybe do that on another stream? Because we have been going about 3 hours now. So maybe it would be good to break it up. But how's everybody feeling?
How am I feeling? I'm feeling pretty good. I know I've been going over a lot of this stuff, so maybe it would be good to take a break and do it later. But I can do the scarf real quick. How about we do the head look stuff another time? But the scarf should be pretty easy, and I think it would be a pretty quick thing to show here, and that way it would be a good way to show the stuff we can do in the anim graph other than just doing a state machine. So we'll do the scarf real quick and then maybe call it, because it's been about 3 hours. That's a pretty long time. So let's do that. So we need to turn the scarf back on. If you remember at the very beginning, we did the material instance here, which is in the test character folder. There's a material instance right here. And if you open that, we had the opacity mask and we turned it, set it to 0. So if we uncheck that, it'll bring it back. So we get this. Save that. So now if we hop into the game, you can see we have this scarf, but it's very stiff, right? It's like a board because it's not animating. The only thing it's doing is when we go to our idle pose, it comes down, because I did, pose it that way in the idle animation. But otherwise, it's very stiff. And we just want to get it, animating dynamically a little bit with that. And the node that I know that's a good one for, roughing in this stuff, if you didn't want to go full on cloth sim stuff,
there's a it looks like a dead man being hung. Yeah, that's true. There's a node in here called a trail controller. And this node, oh wait, sorry, my mouse is being a little weird. There we go. This node, what it does is you define a chain of bones, and along that chain, so the first bone you select, which is this trail bone right here, will be at the end of the chain. So in this case, it would be the end of the very bottom of the cape, the part that's near the ground. And then you define how many bones are along the chain and which direction the bones are facing on the chain. You know, what's the orientation of the bones along the chain. And then what it does is it sort of makes overlap for you by trying to, you know, slowly go down the chain and, you know, smooth it out over time, each bone getting a little bit more movement in it, a little bit more dragging behind. And then it tries to put it in the pose that it is in the animation. So since in our animations, the cape is very straight out behind the character, it's basically trying to put it in that, but it's, you know, overlapping the joints over time so that it feels like it's overlapping. But it's not a full-on cloth sim. So this is great for, you know, more stylized or like a more budget-friendly version of doing this. And I think it works pretty well for our case here, what we will be doing. So first, let's hook it up. So we grab the little white guy, and you'll see that this one is blue, which means that it has to, and it'll automatically add this for you, which is the local to component space. And it'll do the same thing when you hook this one into the output pose. It'll change it back to local. And that's just because this node needs to work, you know, in this different space than it is, you know, the world space stuff that this is, or the local space that this is. It needs to go into the component space. So it'll add those nodes for you. You don't got to worry about it. So now we need to set up this. This one's pretty easy to set up. It's not too bad. And there's a lot of settings in here you can play with, but I'll just show you the quick, easy ones to get it pretty working. So if we click on here, trail bone, it'll give us our hierarchy of all our bones in this character. And we'll want to grab cape 4. The reason that we're not adding 5 is because that one's on the end, and the orientation of that joint is, it's not skinned to anything, and it's not necessarily pointing up the chain, because a lot of, if you've rigged in Maya, you know that like the bone on the very end of a chain usually is not oriented correctly to the rest of the chain. So in this case, we'll grab cape 4. And then there's chain length. So if we look in here, how many bones are in this? 1, 2, 3, 4. I think, I could be wrong. We'll find out in a second. I think you count the bone that you selected first. So let's see, 1, 2, 3, 4. So this will be 4 bones. So we'll say the chain length is 4. And then let's save and compile that. Now, if you look at the previewer, you can see the cape is all kind of twisted up and stuff. And that's because we need to change our bone axis here. So if you're not sure which one it is, you can kind of just guess, and you can try out each one. So if we hit Y, we can see that one isn't right either. So let's try Z, because I don't remember how these are oriented. This one looks even worse. So Y seemed to look kind of right, but it looked backwards. So you can check this invert chain bone axis. And if you click that, now it looks right. You know, it's flowing correctly down the the chain of bones. This guy's really small. That's why the camera's having problems with it. I should have made him bigger. But anyway, so now we can see that that's working. So let's check it out in game and see
see how it feels. So if I start moving, you can see it gets very long, but see how it's nicely trailing behind now, and it gets, it gets this nice overlap, sort of. You can kind of think of it as it's trying to kind of follow along in a path, kind of what it's doing, but it also is really stretching out the cape, right? Like it's getting kind of unrealistically long. So we can limit the stretch on that, and we can play with a lot of settings. So let's see. Let's pull it back over. There is the relaxation speed, which here you can set on this. And if you double click this, I thought it used to open the curve in a little bit bigger window, but I don't think it does anymore. But anyway, this is... this number up here is a multiplier for this curve. So right now, what you put in this curve is going to be multiplied by 1. So it'll be exactly what's in the curve. And what this says is you can set what the relaxation speed is how long does it take each bone to go back to the pose that's exactly in the animation. If that makes sense. So when you move, say you move like this, how long does it, in the animation it's flat like this. It says how long does it take each bone to get, when it changes from here, it sets, the world space of that basically, and then how long does it take to get to this? And that's how we get overlap, is because since this curve is animated like this, it's saying that the bones at the end of the chain, which are at 0, take longer to get to their new position than the bones at the beginning of the chain, which are at 1. So you can play with this to show how, you can actually make this like an ease in, ease out curve if you want. Changing this curve can give you a lot of control and a lot of different results in here. But by default, it's pretty decent. And I think it's a little slow right now. So if you increase this to 2, I believe it'll be even slower. So if we took a look now, okay, I got that backwards. The higher the number, the faster it gets to its new position. So if you make this number higher, or if you made it lower, so if I made it like 0.1, and then we try that, it'll get really long, and you can see this is kind of a little too extreme, right? Like it's taking a very long time to pull it to its position, and then it'll slowly ease in to where it's supposed to be, like that. So you can play with this number, you can play with this curve a lot to get, what feels good. I think 1.2 probably felt pretty good. Let's see what we get. Yeah, that feels a lot better. Let's see, there's a question. Do you know if the tail controller works over top of animation? For example, if you animated the cape, will the animation play and the trail controller will do its overlap over the image? Yes, it's actually doing that right now. In the idle animation here, I have the cape animated to be curved down like this. And when I'm going straight, I have it, it's straight up from the character. So you can see it's animating between the two poses, just like that. Yeah, so pretty much the way that the anim graph here works is that the order of stuff that you hook in here matters. So with our state machine, we're getting our animation posing data from all of our animation assets, and then it's running this on top of that afterwards. And then it's feeding that into the output pose. So there's other things you can do in here, which I think I'll go over next time.
because, like I said, this one's been getting pretty long, and I didn't really get into a lot of stuff here in the anim graph, which can be really fun, and you can do a lot of stuff in here too. But if you notice, like, there's an alpha here, so you can actually get stuff to drive the alpha here. So if I set this to 0, now it won't be doing this because the alpha is 0, so you can blend it in that way. So since the alpha is 0, you can see now it's back to being a stiff board. So you could actually, depending on which animation is playing, you could, or what data you want to feed into the alpha here, you could have it be like, okay, use this trailer or use this trail controller only when these animations are playing, or blend in the alpha the faster you're going, have a higher alpha, or whatever. You can, anything that you hook in a pin, just like we were showing earlier, you can hook into the alpha here to drive it that way too, which is really cool and really powerful when you do it that way. Then there's a couple things here. There's limit stretch and limit rotation. So if we wanted to limit the stretch so that the cape can't get like crazy long, that's a good one to do. We can click the limit stretch there, and then the stretch limit should be down here. So we could say never stretch more than 1.5 times or something. And then if we looked in here now, that feels pretty good, right? Like, it is stretching a little bit, you can tell, but it feels reasonable how much it's stretching now. And it also covers, vertical too. So it looks really nice when you're jumping too, right? And now that I'm looking at it, I'm seeing that I probably added one too many bones to the chain, potentially. Actually, no, I think it's fine. But since this is the trail controller, like I said, and it's not physics, there is no like collision on it. So you can see like that first part, how it's like sticking down into his body a bit. So there is limitations with this one. It's like a cheaper version, but you don't have control over like necessarily adding like physics volumes and stuff that you don't want, or collision, with things. Like, it's not going to have any of that because there's no collisions or physics or anything on it, really. It's just smoothing out the rotations over time. However, you can set up rotation like a planar limit or something. So you could say, I believe the planar limits will work. I haven't worked with them too much, but I think the way they work is they are sort of like a collision, but just on a plane. So you could like set it so that the cape, for instance, could never come past his side plane, so that it could never blow in front of his face or something like that if you wanted to. So you do have a little bit of control like that, but you can't set up like individual volumes and stuff for it. And you could actually set rotation limits too per bone if you wanted to. So I could click in here, and then this is like for each bone you can say how much can it rotate, what are the ranges that it could rotate in. That's also how Anim Dynamics works. Cool. Yeah. So yeah, you can individually set your rotation limits if you want that way. So that's just a couple of settings you can do on here. You can add a fake velocity if you want. There's just a bunch of settings in here that are fun to play with and see what they do. But yeah, this is a great way to add quick, a quick cape to a character, or maybe like a strand of hair or a ponytail, or some small like things that you want to animate as the character moves. Yeah, I think that's probably a good space to stop for today. We didn't go over, if you look in the example that I have here, we didn't go over doing the head look state, which is all of this. And I think that would take quite a bit of time to go into, compared to what we have left. And this is a little bit more advanced than the stuff we were doing, showing how to set up a state machine and stuff like that. And I know we had quite a few, very beginners to Unreal in here. So I want to give you time to, chew on what we just did, and play around with it. Again, I'll link the project file for this. It has all these assets, everything in it, and has all these comments that I've left here. If you didn't grab it before, you can grab it there and play around with it and see what you can get. And then maybe I can figure out next time when we can go over the head look stuff. It might be a couple weeks before I'm able to do it again. I have some stuff coming up next weekend and such, but keep an eye on my keep an eye on the channel. I'll try to, and my socials. I'm Izzy Lizard on Twitter. Also on Blue Sky. Same handle on both. Just keep an eye there, and I'll be able to update you on when I will probably do it again. Let's see. I got a question. Couple questions. What takes more time as a gameplay animator, the work with BP or making the animation in Maya, or is it like a constant go forward and backwards? Yeah, I would say it's a lot back and forth, because at my studio, I'm the only animator. So I'm pretty close to what I'm doing. So I also have to do a lot of this tuning and such in Engine as well. Like I said, we use a bit of custom stuff compared to what's in here, and a lot of that's kind of left over from when my studio didn't have an animator. So there is a little bit, and we're slowly shifting away to giving me more power to do this stuff. But at first it was very much like I would have to go ask a programmer like, hey, I need this implemented, I need to do that. But as we've grown as a studio and such, I've been able to do more and more of this type stuff and learn more and more of this stuff. So it's empowered me to get the animations to look even more like I want without having to relay all this information to a programmer or such. So I would say for me, it's probably about 50-50, honestly, back and forth between the two. And the cool thing is, like, once you get this stuff set up, you can kind of inform yourself how to animate it. You can be like, well, if I animate it a certain way in Maya, then the way I have this set up will make sense. And it might look kind of weird in Maya or whatever, but it'll look and feel great when you're actually playing it. And the other question was, could I explain the main difference between gameplay animator and gameplay programmer? Sure. So like an animator would be doing, what we just did today. But a programmer would be setting up all these systems, setting up like, how does the character move? How does the input work? How do we get all these values, all this information that we use to get, the character's speed and how the character moves, how the character interacts with the level and physics and collisions and making gameplay systems to interact with the character and all of that stuff. That would be more of a gameplay programmer. Not necessarily making the art like we are with the animation here, but getting more into code and how things behave and all of that. If they're doing like NPC AI and stuff like that, that would also be a gameplay programmer and such like that. So yeah, hopefully that answered your question or your questions. Cool. Well, yeah, thanks so much for coming and hanging out today, guys. Hopefully I helped you learn a lot of stuff. I know it was a lot to go over, especially if you're brand new to Unreal and you haven't really done anything like this. You've never opened a blueprint before or anything like that. So, happy to help learn this stuff, because it's a very big program. It's a lot of stuff in here, and it's a lot to take in. So hopefully this was a good intro for you. And please, if you have any questions, please shoot them my way. I'd be happy to help. And like I said, I'll let you know next time I get a stream going to finish up the rest of this demo project here with the headlock stuff. So cool. Hope you have a great rest of your evening or morning, depending on where you are in the world. And I'll see you next time. So thanks again, and good luck with animating and trying to implement some of this stuff. All right. Take care, everybody.